Yeah, good morning, everyone. My name is Amir, and on behalf of EIACP Center Wildlife and Protected Areas Management at the Wildlife Institute of India, I welcome you all to our World Environment Day webinar. This year, we are focusing on the critical theme of land restoration, halting desertification, and building drought resilience. Our slogan, Our Land, Our Future, We Are Generation Restoration, embodies our commitment to revitalizing our planet. I'm honored to introduce our distinguished guest, Ms. Kamana Pokhariya. Kamna hails from Pithoragarh, Uttarakhand, and is currently pursuing her PhD at the Wildlife Institute of India, focusing on the carbon stock dynamics of Panna Tiger Reserve in Madhya Pradesh. Additionally, she serves as a program officer in the Forest Plus program in New Delhi. With a rich background in forest dynamics, remote sensing, climate change, and the human forest interface, her expertise is precious to our decision today. She will be presenting on thriving or striving the dry spells, drought resilience of central Indian dry deciduous forests. We are also joined by our host coordinator, our center coordinator, Dr. K. Ramesha, as well. So, World Environment Day, led by the United Nations Environment Program (UNEP), has been celebrated since 1974, evolving into a global platform for raising awareness related to environment and actions. This year's campaign emphasizes that while we can't turn back time, we can grow forests, revive water sources, and restore our ecosystems. It's about creating a sustainable future for our generations to come. So, together we can make a difference. Let's engage, learn, and be inspired to take action for our planet Earth. We are Generation Restoration, and our work starts now. Thank you all for joining us, and we will be having a very productive session. And if you have any comments, suggestions, or questions, please drop them in the chat box. We'll be taking them at the end of this webinar. So now I would request Kamna to please start her presentation. Kamna, over to you.
Thank you, Amir. Thank you for the introduction and inviting me for this webinar. And I would like to welcome all the participants who are present online. Thank you for taking your time for this webinar. And we are celebrating the World Environment Day 2024 under the theme Accelerating Land Restoration, Drought Resilience, and Desertification Progress. And excuse me. Yeah. And within this webinar, I would like to share a study from Greater Panna landscape, where we have studied the drought resilience of different forest types and non-forested areas within the landscape. The theme of this year is indeed of immense importance, as we are also celebrating the UN Decade of an Ecosystem Restoration. So before moving ahead, let's understand these terms better. In 1994, the UN Convention to Combat Desertification set out some definitions which state desertification as not the expansion of literal deserts, rather the land degradation in semi-arid systems due to the climatic and human factors. The droughts are the prolonged period of water scarcity, and drought resilience is the ability of any ecosystem to recover from these disturbances. These are often interconnected, as the drought events exacerbate desertification by soil degradation and vegetation loss, and the desertification reduces drought resilience as degraded soil loss and water retention capacity. To combat the desertification, drought resilience restoration practices help improving soil fertility and water retention. Here I would like to cite a map from Karao et al., which has predicted the vulnerability of the global at the global scale. And if we see at this map, we can see that the areas which are situated near the tropics, especially the large land masses such as Africa and India, those are the areas which are more vulnerable to the droughts. And these are the areas this will be like in future, as we are witnessing the changing climatic patterns, these are the areas will be more vulnerable due to the any kind of extreme climatic crises. Here, I would like to cite another study from Hammond et al., which shows the global distribution of hotter or drought tree mortality plots. So these data sets are from 1970s to 2018. And if we closely look at this map, we can see that in 2018, or near 2018, the dots which are shown in yellow and light pink color, those are very concentrated in the temperate forest or subtropical forest. While from the deciduous forest and other kind of forest, we are having the mortality data set from 1970s. While in recent year, rather than while we are experiencing more hotter climates and more droughts, there have not been more mortality recorded. So this puts two arguments. First, are these forests resilient to drought, or there are any data gaps? To fill this caveat, we attempted, sorry, yeah, this map I would like to refer. So here you can see on the right hand of the side that the global distribution of the dry forest, and on the left hand side you can see the hotter drought tree mortality plots. And if you see in the India, where the drought and the dry deciduous forests are there, there have not been recorded any mortality here. And same goes for the Australia, and for the Africa there are lesser records. So again, this puts the question, are the tropical dry deciduous forests are drought resilient, or there are some kind of data gaps? In this regard, we carried out a study in the Panna landscape. So as you can see, there are the pictures from Panna landscape from wet season and dry season. So during the monsoon, it turns entirely green, and during the non like dry periods, you can see the landscape contrastically changes. So coming to the description of our study area, the Greater Panna landscape is distributed over 13 districts, covering an area of more than 47,000 square kilometer. It has mainly hot and semi-arid landscape covered with dry deciduous forest type, and the elevation ranges from 213 to 0 meters, and the temperature reaches maximum to 45 degrees Celsius while minimum 6 degrees Celsius. And the annual rainfall here we receive is 1071 millimeters. So to predict the drought resilience, we have followed some step-by-step methods. First, to identify the driest year. Second, to calculate the water use efficiency, followed by to predict the resilience of land use and land cover categories. So to understand the resilience is the ability of any ecosystem to recover to the similar functionality after a disturbance. And in the tropical dry deciduous forest, the recovery time is based on the water availability. And water availability is directly related to the productivity of biomass of the forested ecosystem. So, data set and methodology. So to predict, to calculate the driest year, we have used the standard precipitation index, and we have used the medium term trends in standard precipitation index, which reflect SPI 6. Since our data set was ranging from year 1990 to 2019, so we thought it will be best to use the 6 months SPI, which will be reflecting the medium term trends. So the SPI value ranges from -2 to +2, and the index shows negative values and positive values. Negative values showing the drought conditions, while the positive value showing the wet conditions. And these are the daily graded rainfall data sets from 1990 to 2019 obtained from Indian Meteorological Department. Subsequently, we calculated the water use efficiency. Water use efficiency is the ratio of productivity, biomass, or yield against available moisture, which is typically in form of the evapotranspiration. And the increase in water use efficiency improves the drought tolerance. To calculate the water use efficiency, we use the Morte's net primary productivity data sets, and MODIS evapotranspiration data sets. So for MODIS net primary productivity data sets, we used the MOD17A3 product, which is available from year 2000 to 2019. And same for evapotranspiration, we use MOD16A3 product for the same time period. And as water use efficiency is the ratio between productivity and evapotranspiration, we calculated it by dividing NPP divided by evapotranspiration. And we calculated the water use efficiency for each year. And later on, the mean water use efficiency for 19 years were calculated by averaging all the rasters. For resilience analysis, we classified the area as resilient or non-resilient based on their ability to sustain its productivity during the driest year. The areas which were able to sustain their productivity during the driest year were considered as resilient, while others were considered as non-resilient. For classification of the resilience analysis, we used Sharma and Goyal's equation, which depicts as RD as resilience to drought, where water use efficiency of driest year is divided by water use efficiency mean. The result of RD was categorized within four classes. Resilient, RD is greater than or equal to 1. Slightly non-resilient, RD lies in between zero point 0.9 and 1. Moderately non-resilient, where RD lies between zero point 0.8 to zero point 0.9, and where RD value is less than zero point 0.8, those were considered as severely non-resilient classes. So coming to the results, the result of standard precipitation index for 6 months shows in between year 1990 to 2019. Year 2009 was the driest year. These are the four graphs from four random data points taken from IMD gridded rainfall datasets, and all these four plots shows the similar trend, showing that year 2009 having the lowest value for SPI 6. And when we did some background search, we found articles and newspapers headings stating that the Indian summer monsoon season of 2009 was with a massive deficit, and it was the third driest year in the century in India. So once we have identified our driest year, we wanted to know which are the areas that are resilient within the landscape and which are the non-resilient areas. So for that, we have used Copernicus Global Land Use Land Cover Dataset with a special resolution of 100 meters. And as you can see in the map, that the cropland or agricultural land are the most spreaded land use landed cover class within this map, and the dry deciduous forest are the second largest LULC class within the landscape. And coming to the result of drought resilience analysis, we found that 66.54% of the landscape falls under resilient classes. Slightly non-resilient classes cover 24.32%, while 7.13% classes were categorized and moderately non-resilient classes, while less than 1% for area falls under severely non-resilient classes. So these classes are given based for all the land use land cover types within the landscape. For further clarity, we extracted the forested area only, and we looked at the distribution of resilient and non-resilient classes within the forested area. So here we found that approximately 43.38% of the total forested area is considered as resilient, and slightly non-resilient classes covers 37.65% of forest cover, while 16.51% was considered as moderately non-resilient, and approximately 2% area falls under severely non-resilient. And here, one interesting thing to note that if we see in the previous map also, and in where we extracted the data for forest also, the western part of the landscape is where the most of the non-resilient classes are falling, while in the eastern part or northern part, the classes were classified as resilient. Similarly, we mapped separately the non-forested areas, and here also we follow the same pattern that the western part of the landscape is having more non-resident classes in comparison to the eastern and northern part. So to further investigate this pattern, we to further investigate this pattern, we look at the regional and bioclimatic factors that might be influencing this pattern. So we overlapped the boundary of Bundelkhand region within the final map where non-resilient and the resilient class distribution we can see. So it gives us a clear picture that within the Bundelkhand region, if we see in these two bars, within the Bundelkhand region, the non-resilient classes distribution is 40%, while outside the Bundelkhand region, the non-resilient classes are only 20%. So this has to do something with the unique biogeography of this region. As it falls under the rain shadow of the Vindhyan Range, rocky soil, low water retention capacity, overexploitation of water resources. Additionally, the forested area within the western part of the landscape is also fragmented and degraded. All these factors have been significantly contributed to the distribution of non-resilient classes within the western part of the landscape. So overall, the resilient classes, the distribution of resilient classes, we can say that within our landscape, the 66% of the area has been classified as resilient, while 33% has been classified as non-resilient. And within the non-resilient classes also, we have severely non-resilient classes, a very small portion, less than 1%. But since this area is located in semi-arid landscape, slightly non-resilient classes are also of major concern, as these areas are already water deficient. And the lower water use efficiency will also affect the crop production and can be threat to the food security of nations. Thus, we recommend that continuous monitoring of water use efficiency over the non-resilient areas and investigation or studies on the post-drought effects on vegetation while including the ground data and climatic condition on vegetation health can help us to understand the ecosystem functioning within this area. And lastly, I would like to close this talk by stating that the dry the dry deciduous forests are often overlooked while comparing to the wet counterparts. And the reason behind it might be they are not glamorously green enough, or they are not, or the fact that they are having less carbon content. However, they support millions of livelihoods across the globe and the significant amount of endemic fauna. These forests are most exploited by the human interactions and are vulnerable to the climatic crisis. With that, I would like to acknowledge Director and Dean, Wildlife Institute of India, Dr. K. Ramesh, the supervisor of this study, Wildlife Institute of India, and my field mates and lab mates in WII. Thank you.
Thank you very much, Kamna. So we'll just move on to our YouTube chat. So let me see if we have any questions. So
Yes,
can-
yes, Amit, please.
we can address those questions. So as of now, there is no question. So so let's move on to something. So it is something interesting that I wanted to wanted to ask you. So
Sure, please.
because you have been working on carbon stock dynamics, so
Yeah.
what was the main inspiration about it? I mean, on what inspired you to focus on the carbon stock dynamics of Panna Tiger
Okay.
Reserve, PhD?
So I have been always interested in like forest dynamics, whether
Okay.
it's related to carbon stock or whether it's related to like application applying the remote sensing data sets to assess the forest health and distribution. So carbon stock, I particularly ended up with because it is like correlated with so many other things, with biodiversity, with forest health, with anthropogenic pressures. So that is how I came like onto carbon stock.
Okay. Okay.
Yeah.
And tell us briefly about your journey from, I mean, from because you are from a place, I mean, in the mountains and going down to the plains in the central India. So how was the journey? I mean, what ignited it from Pithoragarh to Uttarakhand? I mean, into Wildlife Institute of India and then to MP in
Well,
India.
frankly speaking, I would say that it it wasn't like the entire plan. I didn't have a plan. It
Okay.
just happened as a part of journey, and I'm glad it happened because it was a beautiful journey. I experienced like lots of things I learned because I don't come from the forestry background. I come
Yeah.
from the geography, and later on I studied remote sensing and GIS. So within the 6 7 years I spent in the central Indian landscape, I learned a lot about that landscape. I learned a lot about forest, wildlife, habitat.
Mhm.
So it's just a part of the journey. So yeah,
Okay. So there's just one question. How does
yeah.
the health of dry deciduous forests in central India impact the larger environmental and climate goals of the region? Because you said ki these are very less spoken and less talked about forests in India. I mean, everywhere. So
Can you repeat the question,
uh,
please?
how, how does the health of dry deciduous forests in central India impact the larger environmental and climate goals of the region in particular?
Okay. So
Yeah.
within the central India, the dry deciduous forest, we have already spoken about it, that the anthropogenic pressures are very high on this. And if you have seen the map of that landscape, you could
Mm-hmm.
see that the agriculture areas all around, and where you see the forested areas, those are the forested areas which are situated on, some cliffs or rugged terrains, or if there are some protected area, so there is the forest. So these are the remnants of forest we have within the landscape, which somehow are improving, helping to improve the water quality of river flowing through those regions, and
Mm-hmm.
somehow improving the um, other environmental services also.
Okay.
So if you see, like those are the very like narrow linear patches of forest. So
Forest.
at a regional scale, I'll say they play a significant role in terms of regulation of ecosystem services or livelihood provision, all those things.
Okay, now we have spoken of livelihood. So, what is the role of community? I mean, in the conservation and restoration efforts over there, how are the community involved? Is there some significant involvement of community as well in the conservation and restoration efforts?
Yes, I will say community is very much involved in this landscape, as I have been working with the protected area, and protection cannot be done without the community involvement, without taking them together. And Panna is a great success story. And if we the community played a very significant role over there also. And there are some other like tribes also reside within those landscape, like which were residing earlier within the forest, but they are now in the fringe areas or outside the forest. So they are very much, aesthetically also and culturally also, they are linked to those forests. So yes, they have played a very significant role in conservation of these forest areas. Yeah.
Nice, nice, nice. So, Kamna, since you have moved out of WI, so what future projects or areas of research, I must say, are you like excited about now? I mean, how is the new place?
New place.
Yeah.
New place is good. Here also the field is same. Here also
Okay.
I'm working on the forested areas only,
Mm-hmm.
like similar work,
Uh-huh.
but in a larger scale.
Large
So
scale.
it's good. Yeah.
It's good. It's good. Thank you. Thank you very much.
Yeah.
So I don't think we have any more questions. So let me
Okay.
just check it out. Yeah. So yeah, thank you very much, Kamna, for your
Thank you.
insightful presentation and for sharing your extensive knowledge on the drought resilience of Central India.
Thank you,
And your
Amir.
expertise has shed some light on the critical importance of adaptive strategies, practical conservation efforts uh,
Yeah.
that need to sustain these vital ecosystems.
Yeah.
So, as we commemorate World Environment Day 2024, we are reminded of our collective responsibility to restore and protect our land. The theme, Our Land, Our Future, We Are Generation Restoration, emphasizes the urgency and potential of our actions in reviving ecosystems and ensuring a sustainable future. We hope today's discussion has inspired all of us to take some actionable steps towards land restoration and environmental conservation in general. So, together we can make a difference and foster a healthier planet for generations to come. Thank you, everyone who has joined us. And thank you again, Kamna. Thank you
Thank you,
for
Amir. Thank you for
and
inviting me.
to, the all the faculty members and the dean and director of Wildlife Institute of India for making this possible. So we'll meet again on 29th. This is for the general viewers. Okay, so we have 29th. There is another webinar aligned. So we'll see you then. Till then, take care of yourselves and see you then. Bye-bye.
Bye.
Oh, see you. Bye-bye.
Bye.